Let's continue where we were last class. So last class we talked about the definition of a limit and also different algebraic techniques of solving a limit. But in this class, the first thing we're going to talk about is a thing called one-sided limit. A one-sided limit is like, it's one-sided, right? So one-sided could be from the left to the right. So when you see x approaching to a value, minus is basically saying x approaching to the value from the left side. So saying from the negative infinity to that value. And when you see a value plus, it's basically saying from infinity, so from the right side to that value. And let me show you what that is on a graph. Let's just graph x 1 over x minus 3. We know x minus, so 1 over x, it looks like this, right? And x minus 3, this should shift to the right by 3 steps. So there's a little shift. There's the vertical asymptote at x equals to 3. And first of all, let's look at the first one. It's saying when limit x approaches 3 minus, so from the left side to x equals to 3. And what is this function going to approach? Let's just see. As x approaching to 3, the value is going to negative infinity. So this value is going to be negative infinity. What about the right limit? So when limit x approaches to 3 plus. So when x is approaching to 3 from the right side, the function is going to infinity. So the value of this one is infinity. What about c? Since it's a two-sided limit, it's basically saying this value is going to approach, the function is going to approach to a value when x approaches to the left side and right side. So two-sided, so both-sided, okay? But the thing is, the left-sided limit is negative infinity, but the right-sided limit is infinity. These two don't equal. So the limit of this function does not exist. It's simply because the left limit does not equal to the right limit. That's why the two-sided limit does not exist. In other words, this function is discontinuous. We will cover that in the later videos. Let's move on to the second topic. What does this function look like? So we know that there's a vertical asymptote at x equals to 3. So x equals to 3. And this function should be larger than 0, which means that this function is going to look like something that's approaching to a value like this. And we can tell this is a double-sided, this is a two-sided limit, which means that we have to evaluate the left limit and the right limit and to see if they're equal. So what's the left limit? So if it's approaching from the left side to x equals to 3, this value is going to infinity, right? What about the right limit? So x approaching to 3 from the right side, the value of function is going to infinity too, which means the right limit equals to the left limit. So the function is, so the two-sided limit exist, and they're all infinity. Okay, let's move on. What is this function? As you learn in AP pre-calc, this is called absolute function. And we know that there's a breakpoint because it could be both negative and positive. If you see, so for this question, the breakpoint is simply x equals to 2, right? And if it's to the left of x equals to 2, it's going to be negative. So the whole thing will be negative x plus 2. If it's to the right of 2, it's going to be x minus 2. It's going to be positive. So the graph simply looks like this. As we know, x cannot equal to the value 2 because that will make the function undefined. And now we can evaluate the limit. So the first thing we're going to do when we see this is to see if it's a right limit or left limit. So in this question, it's a left limit. which means we're looking at a graph. We're looking at this one, the graph of this. And we can simply just move. We can simply, eliminate. We can simply cancel the absolute sign because it's a negative, right? So the whole thing will be negative x minus 2 divided by x minus 2. These two canceled out. The whole thing is just going to be negative 1. What about this one? Since it's approaching from the right, so the whole function will be positive. So we can just move out the absolute value, be like this. So the value of this one is 1. Or you can see it from the graph. As we know, the value of over here is negative 1, and the value of over here is 1. So if it's a left limit, it's approaching to negative 1. If it's a right limit, it's approaching to 1. Again, what about the two-sided limit? As we mentioned before, the two-sided limit exists when the left limit is equal to the right limit. So apparently, negative 1 does not equal to 1. So we just simply put D and E does not exist. I'll be introducing a new function called a step function, or the greatest integer function. It's basically saying that y is the greatest integer that's less or equal to x. For example, we have y equals to 0.01. It's the greatest integer, but the smaller than this value, we can get 0. And then 0.1 is still 0. Even 0.99999, the step function is still 0. If it's 1.5, is 1. You don't round it up, and you don't round either. We only look at the greatest integer that's less than the value of this one. What does that look like on a graph? We have y equals to a step function of x. The way we can graph this function is by looking at different interval. So first of all, when y equals to 0, what does that look like? So when x equals 0 is 0, right? So of course it can be, we have to put a close dot over here because it can be equal to 0. And when it's 0.1 or 0.5 or 0, all the way into 0.99999, it's still 0. But when x is equals to 1, it's no longer 0. It's going to be 1. This will get to our second interval. So the first interval is just going to be this, and I have to put an open dot over here. This is at x equals to 1 because it can equals to 1, right? And then the second interval is that when y equals to 1, when x equals to 1, y is 1. So we can put a close dot over here. And when x equals to 1.99999, infinite close to 2 is still 1. But when x is equals to 2, is no longer 1. It's going to be equal to 2. So we'll have to go up to 2. So the whole thing will look like, I'm going to put that over here, and then a close dot over here. And then we just repeat a pattern. This is the same thing for negative. You go one more down. We see there's a x minus 2, which means we have to shift the whole function to the right by 2. Just a little shift by 2. So we're starting at 2. Ooh, just a little cropped, but should be fine. You get the idea. And now, what is the value of when limit x approaches to 1 minus? So it's approaching to 1 from the left side. This is x equals to 1, right? And the same from the left side. So it's from the left side. We need to know what this value is. So each function has to go down by 1. So this is -1. this one is just going to be -2. So the value of this one is -2. What about when limit x equals to 1 plus? So from the right side, when this add x equals to 1, from the right side, you're going to get -1. Again, this is a two-sided function, and its left limit does not equal to its right limit. So we just simply put D and E. There's a simpler way to approach this problem by not drawing a graph, is that you can just plug value and to see if it works, right? For example, the first one. When x approaching from 1 minus, so it's approaching from the left side. So we can simply put a value that's less than 1, but kind of close to 1. For example, we can put -5. It's still smaller than 1 and it's close to 1. So what is 0.5 minus 2? This is going to be -1.5. What's the greatest integer that's less than -1.5? Which is -2, right? And it's the same thing for x is 1 plus. We can find a value that's larger than 1, but it's just kind of close to 1. Let's just say 1.5. So what is 1.5 minus 2 and the step function of it? This is simply -0.1. And we have to find the greatest integer that's less or equal to x. And x over here is -0.5. So the value over here is -1. Because it's less than, I didn't say integer. Let's look at these two examples. How do we solve this? We can solve it by using limit property Let's look at these two examples. How do we evaluate these? We can solve this by using limit properties, by splitting them up. So the whole thing can be split as x approaching to 2 minus x cubed times when limit x approaching to 2 minus x minus 2 divided by x minus 2. Don't forget the absolute value. We just have to split the whole equation into functions with limits that we are familiar with. And now we just have to evaluate two limits. What's the value of this one? Since x cubed is continuous, which means the right limit and the left limit, they're equal. So we can just simply plug x equals to 3 in to evaluate a two-sided limit. Plug x equals to 3 in, we can get 2 cubed times, as we know, we just have to, since it's approaching from the left side, we just have to put a negative sign over here, and then we can take out the absolute value divided by x minus 2. Cancel it out, so the whole thing will be -1. So the value of this limit is -8. What about this one? Again, it's the same thing. We just have to split the limit into functions that we're familiar with by using limit properties. We're pretty familiar with this, and this. So we can split the whole limit into 3. We can get, when limit x approaching to -2, x cubed times the step function, x approaching to 2 minus. And also times, because we know that we divide a function, we basically time is reciprocal. We can get with limit x approaching to 2 minus 1 over x minus 2. The value of this one, as we know, is 2 cubed is 8. What about this one? It's the same approach. We plug in a value that's close to 2 but less than 2. For example, we have 1.5. What's 1.5 minus 2? The step function of this one. or on the other hand, what's a set function of negative 0.5? It's negative 1, right? This is negative 1. What about this? You might see it. You can just kind of draw the picture on your head, or go back to the previous questions. When x, these two, the first example, these two functions are basically the same, right? So the project from the left side is always going to negative infinity. So the limit of this whole thing is going to be negative infinity. And a times negative infinity is basically a times infinity. And a times infinity is still infinity because it's simply infinity. It's infinitely large. Let's move on. Let's look at this example. We have to be really careful when applying the properties of limit, because if this approach leads to a result of, for example, like 0 times infinity, or the limit properties do not help you to determine the answer, 0 times infinity is an undetermined form. We will later on study this form later in the year, so right now we just have to we cannot use the limit properties. We gotta instead use a way to kind of like simplify a little more, right? So we know the x squared minus 6 minus 6, so x squared minus x minus 6 is basically x minus 2 times x plus 2 divided by x minus 3. There's a whole, so we cancel this out. We just have to evaluate when the limit x approaching to 3 plus x plus 2. We know that this function is continuous. The left function, there's no hole, there's no breakpoint or something like that, so we just have to plug x equals to 3 in to evaluate, to kind of treat it as like a two-sided limit. So it's basically 3 plus 2 equals to 5. Let's move on. We can skip this one. It's pretty repetitive. Let's try this one. These are basically practices of the algebraic techniques of limit. Feel free to pause the video and try on your own. We can simplify this whole thing, right? We can get when the limit x approaches to 0, x squared minus 10x plus 25 minus 25 divided by x. This is x squared minus 10x divided by x. So x got cancelled out, we're left with x minus 10. We just have to evaluate the limit of this one when x is approaching to 0. When you plug x 0 in, you're going to get negative 10. These are more practices. Again, feel free to pause the video and we can compare answers at the end. What's this one? We talked about it in the first video. We can simplify, we can combine these two fractions into one. So we can have limit x approaching to 0. The numerator is going to be 4 plus x. Sorry, this is not 1. We're missing a 4 this side, so it's 4 minus, we're missing a 4 plus x this side. So it's basically 4 minus x over x. We can simplify a little more. We get negative x over 4 times 4 plus x times 1 over x. X cancels out. We are getting x approaches to 0, negative 1 over 4 times 4 plus x. We can just plug x equals to 0 in. We can get negative 1 over 4 times 4. It's basically 1 over 16. What about this one? Again, like what I said before, we don't like square root. So a way to eliminate square root is by timing, is by multiplying its conjugate. So we multiply whole thing by x, the square root of 25 plus x plus 5. Don't forget the denominator, the square root of x 25 plus x plus 5. Simplify a little more. We're getting limit x approaches to 0, 25 plus x minus 5 squared, 25, divided by x square root of 25 plus x plus 5. Sorry. Over here, 25, x, they're gone. We only have to evaluate the limit x approaches to 0, 1 over square root of 25 plus x plus 5. We can plug in x equals to 0. We're getting the square root of 25 is 5 plus 5 is 1 over 10. What about this one? What is this? And how can we simplify this? So numerator is basically x plus 3 times x minus 5 over, this is basically 3 cubed. So the whole thing can be simplified as x plus 3 x squared minus 9x plus 9. These two cancels out. We're getting x minus 5 divided by x squared minus 9x plus 9. Sorry, I made a mistake. This is 3x. Because we don't change this, because it's 3. Now we just have to evaluate this limit when x approaches to negative 3. We plug in x equals negative 3. So it's negative a minus 9 plus 9 plus 9. So the whole thing will be negative a divided by 27. What about these two? Again, we can use limit property to split them up. We can get with limit x approaching to 2 minus 3x times limit x approaching to 2 minus x minus 2 divided by x minus 2. The value of this one, since it continues, we can just plug x equals to 2 in. We can get 6 times, since approaching to the left of the breakpoint, so the absolute value is gone. We're left with a negative sign times negative 1. This is negative 6. And also this one. Split them up. We limit x approaches to 2 minus 3x times limit x approaches to 2 minus the step function of x minus 2 times limit x approaching to 2 minus 1 over x minus 2. The value of this one is basically plug x equals 2 in. So is 6 times, what is this? Again, we plug in a value that's smaller than 2, but close to 2. Let's just say 1.5. So when we find minus 2, the step function. This is negative 0.5, the step function. This is basically negative 1. So we have times negative 1 times, you're pretty familiar with this. It's sort of function like this. From the left side, you're going to infinity. So the value of this one is negative infinity. Negative, negative is gone, so 6 times infinity is still infinity. We have two important rules that you really have to remember. The first one is when limit theta approaches to 0, the value of sine theta divided by theta is 1. We have to memorize this, so I'll mark it in red. The second one, when limit theta approaches to 0, 1 minus cosine theta divided by theta. Remember this? This is 0. Let's try two problems. The first one, how do we evaluate the limit of this? See, when these two are equal, so when theta approaches to 0, the value is 1, right? But this is 4x. But how can we make it to 5x? Because we know with sine 5x, blah, 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 divided by 5x, when x approaches to 0, this is 1. But how do we change 4x to 5x? We can simply times everything by 5 over 4. Don't forget this part, times 5 over 4. So your denominator will simply be 5x, and your numerator is going to be 5 over 4 times sine 5x. And we just have to evaluate the limit of when x approaches to 0, the value of 5 over 4 times sine 5x divided by 5x. We know these two, this is 1. So the value is basically 5 over 4 times 1 is equals to 5 over 4. What about this one? We can use the limit property. Let's split the function up. We can get 2x divided by x plus sine x divided by x. And we can split them up. So is when limit x approaches to 0, 2 plus limit x approaches to 0, sine x divided by x. The value of this is basically 2 plus 1 equals to 3. This is a calculus BC, so AP calculus BC exclusive theorem. We call it squeeze theorem or sandwich theorem. What it means is that, let's say a function is between two functions, right? And it's saying, well, limit, when this function is approaching a certain value, and we evaluate the limit of this function approaching a certain value, if these two values are equal, they're both equal to L, the limit of the middle function, that's what we call a squeeze the function, is also going to be L. I can show you the squeeze theorem on a graph. Let's say we have a function f of x g of x, let's just say. This is the tallest function, and we have f of x. I'll change the color. This is below g of x, f of x, and h of s, which is below f of x. This is h of x. So when h of x approaches a certain value, g of x, and then when h of x approaches a certain value, we know the middle function is also going to approach to that value because it's squeezed to a certain value. let's just try an example. We're trying to evaluate the limit of f of x. So instead, we can try to evaluate the limit of the two functions from size first. So it's basically when limit x approaches to 0, 2, you're going to get 2, right? And what about when limit x approaches to 0, x squared plus x, this is still 2. Because the below function is equals to 2 and equals to the value of the upper function. So we know for sure that the limit of the middle function is also going to be 2. This is basically squeeze theorem. Let's move on to our last topic, is limit at infinity. This is more like a recap of whatever you learned in AP Pre-Calculus. Of course, I learned saying that bigger below y equals 0, meaning if the bigger power is as its denominator, so the limit of the whole thing, or the horizontal asymptote, is equals to 0. If they're equal, coefficient divide. If it's bigger on top, you stop, or you can see the pattern, or use like a synthetic division or a long division to see. And I'm pretty sure you learn how to evaluate this. Is that we divide the numerator and the denominator by the highest power of x in the denominator. For example, of this one, the highest power of x is x, so we divide the whole thing by x. So we have limit x approaching to infinity, 3 minus 1 over x, 2 plus 5 over x. And we plug x equals to infinity in. 1 over infinity is going to be 0.0000 infinite 0. So this is approximately 0. And the same thing as this one, this is approximately 0. So the whole thing will be 3 over 2. Again, it's the same thing for negative infinity, because 1 over negative infinity is still 0. So this will also be 3 over 2. What about this one? So we divide the whole thing by x. So this is going to get 3x minus 1 over x divided by 2 plus 5 over x. If you plug x equals to infinity in, these two are 0. But we are left with a limit x approaching to infinity, 2 over 3x. And we can kind of see what this is on the graph, right? So there's a linear positive function. When x approaches to infinity, it's also going to be infinity, right? So the value of this one is going to be infinity. And when it's approaching from negative infinity, so basically 3 over 2x when it's approaching to negative infinity. So approaching like this. So the value is going to go down. So this is negative infinity. Again, use the rule that you memorized it, or you can divide the whole thing by x to the power of square. No matter what, you're going to get a value of 0. Don't forget the rule, bigger below y equals 0. So these two are both 0. Okay, what about this? These two are a tricky one. But we can apply the same rule. We divide the whole thing by its highest power. But what is its highest power? Its highest power is the squared root of x squared over here, right? So, we can divide the whole thing by the square root of x squared. And we know the square root of x squared is x absolute value, right? So the whole thing can be simplified as limit approaching to infinity, 2x divided by the absolute value of x divided by 9 plus 4 divided by x because it's inside of the square root. We just plug x equals to infinity in. But what about this? Since x is approaching to infinity, it's going to be a positive value, right? So we can remove the absolute sign 2x divided by x because it's positive over 9 plus 4 divided by x. X cancels out. We have 2 over the square root of 9 minus 4 divided by x. We just have to evaluate the limit x approaching to infinity. We're going to get 2 divided by, this whole thing is 0. Over 9, we're going to get 3. 2 divided by 3. It's the same thing for this one. But it's just that it's x approaching to a negative value. So when we remove the absolute sign, we have to put a negative. So 2x divided by x and negative sign over the square root of 9 plus 4 over x. When you plug x equals to negative infinity in, we're going to get negative 2 divided by the square root of 9. So the whole thing is going to be negative 2 divided by 3.